Telecompaney Transforming Coils Douglas Konzen. Sponsor of program Svetlana Konzen. Stage producer Svetlana Konzen. Operator Douglas Konzen. Sponsor of program Douglas Konzen. Movie Transformer Experiment Coils Number Infinity. Big experiment all in your mind.
Alrighty, so I wound up 4 coils. This is Big Mama. This is 28 gauge wire. And this is going to go on the other transformer I'm working on. Remember, these are line reactors. You buy a line reactor and then it has this removable bar, so then you can pop in different coils what you want to do. Here's this coil. I took this out here because I want to explain how I think this works. So it runs on AC. So what happens, think of the first sine wave of AC comes in, half wave comes in, and it's positive, and it goes into the coil, and it induces this leg to be what it will be, considering which way it comes in. Let's say it's positive. It's either going to be a positive magnetic polarity or it's going to be a negative magnetic polarity. Just thinking about magnetism here. And so this, let's say this, the way it's wound makes this positive, okay? So that means the flux will go up here, down here, down here, and down here, like this. Thinking because this has been induced in a particular polarity. And of course, when the next cycle of AC comes in, it's going to be going around this way. Okay, so first one goes like this. And the second one goes like this. And remember, this is a 3-phase AC transformer, more or less now. But you're not sending in 3-phase power, coming in. You're only messing with one pole. So when you induce this to a particular polarity, it's going to create this flux path like this. And then when the other one comes in, it comes around like this. Okay, so I think everybody gets that. Now, what's interesting, I left this coil off, and there's just some Teflon tape here because I want to illustrate this. What the back EMF does, so the back EMF is an opposing magnetic force. So it's going to be, so if you're going around this way, it's going to want to shoot. It's going to be shooting back this way. Now, if this is the secondary, the back EMF occurs when this is loaded, the secondary. And what happens is so let's say it's the current flows this way, back EMF is this way. Now when it gets to here, there's actually a fork in the road. It can either go down here or over here, like this. See that? And the same thing when the polarity is going opposite on the next half cycle of the AC sine wave, it's going to be going around like this. I mean, it'll be going like this time. And now the back EMF comes down because it's opposing the current flow, which is this. Current flows this way. So the back EMF is going to shoot this way. And instead of messing, instead of going this route, it has a choice. It can go this way, or it can go this way, the back EMF. And because, let's say the current's going like this and the back EMF comes like this, it's not going to want to go into this secondary. It's not, because it's going to be an opposing magnetic force coming down here. It's going to want to go this way, up and up over here. Now what you want to do is have the back EMF forces slam into themselves over here. A collision, head-on collision, and it'll eliminate the back EMF, so there's no back EMF problems. That's about as simple as I can figure it out. So anyways, one moment I'll show you the coils I've wound up. Okay, so here's the other transformer. See, I have this clamp ready to clamp down this. Last video I was showing the importance of having this, a lot of pressure on this crossbar. So this coil is going to go right here on this one. And on that other one, it has pretty thin coils. And so I've wound up 3 of 28 gauge wire, not 36. So this is I'm going to make this the primary. It should be, this should make that core resonate. And then I'll have a secondary, and I don't know if I'm going to go with 3. And then, you know, you short out this one, or you put a really big cap, 100 UF cap or so, or over it or not. But anyways, so this is going to go on here. I have this one already wound. It's like a ridiculous ohms, about 660 ohms. And this one is the one I had on there previously, and this is supposed to be the power coil, and I'm just going to see how this works. I don't think I'm going to be keeping this, but I'm going to put this on here. And what else do I want to say? So when you the purpose is this primary here needs to put the whole core into resonance. So it's just vibrating like crazy, oscillating. And so that's how you get this power made in the secondary, or if the secondary is over here, is it's coming through the core in a ferro resonance. And if you think about it, if this the first half cycle, if this is north and this is south, then that means this is going to be, if this is south, north and south, this is going to be north and south, like this. And it'll be 120 degrees out of phase magnetically between this one and this one and this one, So they aren't going to be latching up, causing problems because they're isolated. So this is my second attempt trying to explain what's going on, and I think I'm getting better at it, but the purpose of the primary is to put the whole core into resonance, ferro resonance. And the way you have low draw is you have a high impedance coil here, so you don't draw much, but you can still put it into resonance, while the secondary, whether it's this one or this one, can be a coil that has is putting out a lot of power, but it's not feeding back EMF back into the primary. And that's how you get this without the back EMF messing up the primary, making extra draw for every time you make power. Then that's how you get this extreme over unity going on. So I have these coils, so I'm going to be popping one coil in, see how it works, try it with this one, and then all these caps. I got 1,000,000 caps. So I'll be experimenting until I find where it works the best. Okay. Guess that's about it for this. Hold on a sec.
Experiment go and see you later, alligator. See you next video. Enjoy. Thank you very much.